Okay, guys, this is going to be our last section on chapter 2. Okay, and so it's about combining functions. Okay, so if we have two functions and we want to add, subtract, multiply, or divide them, it's really, really simple. Okay, here's what the notation looks like. Okay, so this, when we see this f plus g of x, and that's how it's read, right? It doesn't have, remember, function notation has nothing to do with multiplying here when we see this parentheses next to each other, but it's read of x. So f plus g of x just means, oh, we're going to take the function f of x and we're going to add g of x. F minus g of x, we're going to take the function f of x, whatever it is defined as, and then we'll subtract g of x from it. Same for multiply and divide. Okay, so it's really, really basic. If you saw these things, it's exactly what you would do normally without any instruction. So let's look at that. Oh, first, let's talk about the domains. Okay, so, and now when we're talking about functions, we nearly always also have to consider the domains. But think about this, the only time that I have a problem with domain, remember, when I'm looking at an equation, is if there's a radical in it, right? If there's a radical or a variable in a denominator, a variable under a radical or a variable in a denominator. Otherwise, my domain's just all real numbers. So to find the domains of all of those combined functions, right, then we just find the intersection of their domains, right, wherever they intersect. In other words, parts of the domain that's true for each of them individually, where they overlap, will be the domain for each of those combined functions, with the exception of when we have a fractional number, then we've got to make sure that we leave out that value that makes the denominator 0, right? Just like we've already talked about. All right. So this says we've got two functions. F of x is x squared plus 1. G of x is 3x plus 5. And first of all, we want to find f plus g of 1. I've got two choices on this. Okay, I'll show you both choices and then you can do what you prefer, but I'm going to do the second choice and do it for all of them from now on, just because that gives me a lot of practice in what if this was a variable here and not something I could actually evaluate. So my first choice is I could actually just find f of 1. Right, remember what that means. So I would take the function f, and everywhere there's an x, put a 1. So have 1 squared plus 1, so 1 plus 1, or 2. And then find g of 1. So if I plugged a 1 in here, I'd have 3 times 1, so 3 plus 5, or 8. And then add them together. So f plus g of 1 equals 2 plus 8, or 10. So if we have a numeral, that's one option. We can just evaluate each one individually. Okay, but we also could say, okay, well, let's find just the function f plus g, right? And I can shorthand that notation. I don't have to say f plus g of x every time. I could just say f plus g, and I could just write f plus g. So let's find f plus g, which would be x squared plus 1 plus 3x plus 5, okay, which would be, combining like terms, x squared plus 3x plus 6. And then I could find f plus g of 1 by plugging a 1 in everywhere. So 1 plus 3 plus 6 equals, voila, 10, which we already knew. Okay, yes, on this one, that first way maybe was a little easier and a little shorter. Once again, I'm going to do it this way just to get that extra practice of just finding f plus g of x, because that's what you're going to be doing the majority of the time. That's what I really need to be versed at. So here, f minus g of 3, well, first of all, I'm just going to find, so it doesn't get too cluttered, I'm just going to find f minus g. So that would be x squared plus 1 minus. Now be careful, when we have a minus, I'm subtracting that whole function g. So I don't want to just put minus 3x plus 5. Okay, so this is x squared plus 1 minus 3x minus 5, or x squared minus 3x minus 4. So then f minus g of 1 equals 1 minus 3 minus 4, or minus 6. Okay, f times g of 5. So f times g means just multiply f times g. Okay, so distributing here, we have 3x cubed plus 5x squared plus 3x plus 5. There are no like terms, so it won't simplify any further. So if I had fg of, no, we're not doing 1 now, unfortunately, since we have a cube there, right? Let's see, fg of 5, then I would have 3 times 125, right? 5 cubed is 125, so 375 plus 25 times 5 plus 125 plus 15 plus 5. So this would equal 520. Okay, and then f over g is the function f, x squared plus 1, over the function g. Okay, so f of g of 0, plugging in a 0, 0 plus 1 is 1, over 5, because 0 plus 5. Okay, so if we're evaluating these combined functions at a particular value, if we have a numeral here, then we've got a couple of options. And it's not too bad, right? Combining functions not bad at all. Okay, but now we don't have a numeral, we're just trying to find the new function. But that's okay, because that's what we just did before. Although this one also asks us to give the domain for each one. So if I'm combining functions, first thing I might want to do is find the domain of each one. Remember, if I do not have a radical or a denominator with a variable, then my domain is all real numbers. So for f, my domain is just negative infinity to infinity. Okay, and for g, though, I do have a radical. So I have a, I hope I don't sneeze in a minute, guys. I keep trying to sneeze, sorry. I do have a problem with my domain. So remember, when we're doing that, if it's the radical, you can't take the square root of a negative number and stay in the real numbers. So I would say, well, whatever's underneath there has to be greater than or equal to 0. So if I solved this little inequality, I would find that x then must be greater than or equal to 1/2. So my domain is 1/2 to infinity. Now the domain for all of these is going to be the same, with the exception of this one. It's going to have one extra caveat, right? So it's the intersection of these 2 points. Of these 2 intervals. And so since this is just everything, the intersection winds up being just this piece. So this is going to be the domain for every one of these, plus an extra consideration here. We'll talk about that when we get to it. Okay, so f plus g of x equals, just to save room here, equals, okay, I just take the f of x and add the g of x. Okay, since I do not have any like terms here that I can combine, that's it. And my domain, and notice it's pretty obvious that your domain, oh, I still have this to consider. So my domain is 1/2 to infinity. Same thing here, f minus g of x, we just take the function f and we subtract the function g of x. I don't have any terms I can combine, so I'm finished, and my domain is still that 1/2 to infinity. Okay, here I just multiply the 2 functions, so I have 8x minus 9 times square root of 2x minus 1. Now ideally you could distribute this, and I'm going to do it just for us, but your homework on these combined functions and composite functions when we get to the next one is pretty easy on letting us just leave these radicals in this format. So either one of these will be okay, and your domain in reality this one, but your homework's going to let you just leave it there, I believe. And your domain is the same thing as the others. Okay, same thing here. If I were to divide those, I'm going to move it here a little bit, then we would have the function f over this radical. And again, now really, in reality, we should never ever leave a radical in the denominator. I don't know why this section on your homework is going to allow you to do that. So it's going to let you do this. In reality, remember, we should really multiply that denominator by the square root of 2x minus 1 to get rid of the radical in the bottom, and then same thing on the top. But it's going to let you leave it only in this section only, which is a little annoying. Okay, now I have an extra consideration because I can't let this down here actually equal 0. So instead of, notice if I put a half in here, that's the value that makes it equal 0. Greater than or equal 0 is a half. So instead of putting a bracket on that half, I need to put a parenthesis to say, oh, the half is not included. I have to get rid of the value that actually makes that denominator 0. Okay, so combining functions, like I said, they're super, super easy, I think you'll find. Okay, this is something called the difference quotient. Okay, the difference quotient, we're not really here in college algebra to explain what it is and how you use it. That's for calculus. So when you get to calculus, you will find out what the difference quotient is, what it's used for, and you will use it over and over and over and over. And you will be expected to know how to do the algebra behind the difference quotient. So it's really important when you finish a college algebra course that you can evaluate the difference quotient. So, where do really important things wind up? You bet, on tests. And this one is so important, guaranteed it's going to be a test question, and 95% of the time it's also a final exam question. Okay, so make sure that you practice that difference quotient. Okay, you don't have to remember right now, memorize what the difference quotient format is. It'll always tell you this, here's the difference quotient, evaluate it for this function. Okay, and when you get to calculus, you'll have to memorize what it is. But for us, first of all, I'm just going to do each step individually, and then we'll see how we can put it all together. So if I was going to find f of x plus h, just think about what that means. It means take your function f, and you're going to substitute x plus h everywhere that there's an x. So we would have 2 times x plus h, all squared, minus 3 times x plus h instead of just x. Okay? And then f of x, we're already given f of x. So f of x is 2x squared minus 3x. Okay? So now, here's my two functions. I'm just going to subtract them. So I'm going to take this first function, and I'm going to subtract the second function. So be careful. Make sure you get your parentheses in there when you're subtracting, or remember to change your sign as you write it. So here's this whole top part. This is what f of x plus h minus f of x looks like, and then it's all just over h. Okay, just over h. Not f of h, just h. So here's my difference quotient. Of course, we got to simplify it, right? We got to multiply all this out. So before I do that, I'm going to go back. Now, here's one thing you could do. You could do each piece individually and then put it all together if that helps you. Or I'm just going to do it all together. So f of x plus h means I'm going to have 2. Everywhere there's an x, I'm going to put x plus h. So there's f of x plus h. And then minus f of x. So it's just as it's given us. And then it's all over h. Now all that's left is to simplify this thing. Okay, so we would have that equals, look, here's that perfect square trinomial again. It's really useful to know how that multiplies out in one step instead of having to write x plus h, and distribute. Square the first term, multiply them together, so xh, and double it, and square the last term. Now distribute that negative 3 minus 3x minus 3h. Distribute that negative 1 minus 2x squared plus 3x. And it's still all over h. Okay, now let's distribute that 2. And look, as I'm going along and combining like terms, look, I have this minus 3x plus 3x. So now I've got 2x squared plus 4xh plus 2h squared minus 3h minus 2x squared all over h. Oh, now look, here's 2x squared minus 2x squared. So I'll wind up with 4xh plus 2h squared minus 3h all over h. And I notice they all have a factor of h, and anytime I can simplify a fraction, I must do it. So let's factor that h out and leave 4x plus 2h minus 3 all over h, so that I can eliminate that. So finally, my difference quotient value is 4x plus 2h minus 3. Okay, so important. Where's it going to wind up if it's important? Right. All right, so practice those. Let me know if you need any help, have any questions. Okay, and then another way of combining functions is to take what's called the composition. These are called composite functions, or the composition of functions. And here's the notation. They've got a pretty big O there, but really it's like, it's a little O like that. It's not really an O the same size. It's just a little open, so a little bigger than your multiplication dot with a little open circle. And it's not fog. Please don't read it fog and golf. It's f of g. That's how it's read, because what this notation stands for, it stands for this. So you can write it like this if it helps you. Okay, so remember our notation f of 2 just means to take a 2 and plug it everywhere there's an x. So f of g of x means take this function and plug it everywhere there's an x. Okay, and then we also have g of f of x. Two different things, right? So we got to pay attention to our order. This one we're plugging f into g. This one we're plugging g into f. When we do composite functions, the domain, first of all, we find the domain of the second function. So I'm going to find the domain of g when I'm doing f of g, and I'm going to find the domain of f when I'm doing g of f. Okay, and then I do an intersection with that and whatever I get for an answer here. All right, so we'll look at what that means. Okay, so once again, I could do these individually. I could find f of 2. No, I couldn't. I could find g of 2 and then plug that into f, right? That's what this means. I could find g of 2 and plug it into f. Here I could find f of negative 3 and plug it into g. I'm going to, just for practice of doing f of g and g of f, we're going to do it the old standard way. All right, so if I want to find f of g, that means I'm going to take the function f, and everywhere there's an x, I'm going to put this, g. So 2 times 4 over x minus 1 minus 1. There it is. That's f of g. Here's 2, x, which is that, and then minus 1. Now, I need to simplify. Technically, if I'm plugging in numerals, I don't even have to simplify. I could just plug in and do the math, but just for practice here. Okay, so remember, this is as if it's over 1, so you just multiply numerators and denominators straight across. So we have 8 over x minus 1. Okay, minus 1, and if I want to, if I didn't have a numeral here, at any point when you have a numeral, you can just plug in your number and evaluate. But I'm just giving us extra practice on how to just do the f of g when it's f of g of x. So I would need to do all the math I can do, add my fractions, combine any term. So I'd need a common denominator. Now once the denominator is the same, I can write my fraction with that denominator, and I would have 8 minus x plus 1, right? Because minus x minus minus 1, because these numerators is as if there are parentheses around it. Okay, which is then minus x plus 9 over x minus 1. So if it asks me to find f of g of x, there it is. But I want f of g of 2, so I just plug in a 2 everywhere there's an x. Negative 2 plus 9 and 2 minus 1. So that's 9 minus 2 is 7 over 1. Okay, same thing here, except we're doing g of f, so we're going to start with the function g, and I'm going to plug f into it everywhere there's an x. So 4 over, oh, there's an x, so I need to make that 2x minus 1, and then finish my actual original equation there. So there's g of f. So 4 over 2x minus 2. Look, they all have a factor of 2. So I can simplify that by factoring out that 2. Okay. Let's cancel this and make it 2 over x minus 1. Notice f of g and g of f nowhere close to the same thing. So I got to be careful about my order. Okay, start with f, put g in. Start with g, put f in. Okay, but this question actually asks us to find g of f of negative 3. So I would have 2 over negative 3 minus 1, or 2 over negative 4, or negative 1/2. Okay. Okay. Now it says the same thing except we're not evaluating at a numeral, so we're just doing like the first part we did there. F of g, oh, and its domain this time. Since we're not evaluating, we're going to be left with a function, so we need to state its domain. You know, on the previous ones, when you're evaluating at a numeral, you get a numeral answer. You don't have an equation answer, and so there's no domain to think about. All right, so I'm going to start with f, and I'm going to plug g in. So f of g, okay, means square root, and x is going to change to 4x plus 2. And there's nothing else to do, so there we are. That's f of g. So in this case, in these combinations and compositions, the radicals actually make my work easier. Okay, now domain. If I'm doing the domain for f of g, first of all, I need to come up and find the domain for g. Well, I don't have a radical or a fraction, so the domain's all real numbers. And then I'm going to do the intersection of it and my final answer. Okay, which means just this, because this is all real numbers. So I need to think about, okay, 4x plus 2 has to be greater than or equal to 0. So if I solved that for x, right, 4x has to be greater than or equal to negative 2. X has to be greater than or equal to negative 2/4. So x has to be greater than or equal to negative 1/2. That's my domain, because if I intersect it with the real numbers, this is where they overlap. So the domain is negative 1/2 to infinity. Okay, if I'm doing g of f, I'm going to start with g, and then I'm going to plug f in. So g of f is, let's see, 4, but instead of x, I've got square root of x, okay, and then plus 2. Again, there's no simplifying, so I'm finished. Now to find my domain, I need to find the domain of f, okay, which is, okay, it's got a restriction on it. X has to be greater than or equal to 0, and intersect it with this one. Oh, but it's the same. So the intersection, they both cover the same parts. So 0 to infinity. Okay, and let me make a point here. This was just a coincidence. You might be thinking, well, why don't I just find this domain wound up being this domain wound up being this domain? Why did I have to go back and consider these? Because sometimes that changes this domain. You have extra considerations. On this, it wound up being the same, but I cannot just look at the domain of my final function. I always have to go back and consider the domain of the function that was plugged in. Hopefully in the next example, they'll give us one like that so we can see that, yeah, it's not always just the domain of my final answer. Okay, let's try one more. Yep, I think this will do it. Okay, let's try one more. So f of g, okay, means I'm going to start with f and I'm going to plug g in. So here's f. So I have 6 over, and if I plug g in, then I'm going to change this to whatever g is. So 1 over x minus 3. Okay, so technically there's my f of g. But I hope we know, now this is prerequisite information too, so if you have trouble with this, let me know. But I hope we know that we can't leave fractions in fractions. These are called complex fractions. So I need to simplify that, right? It's simplifying a fraction. We always have to simplify fractions. So what I'm going to do here is I'm going to combine these, right? Simplify this first. So I need a denominator of x in the numerator and denominator so that I can add those together. So this is 1 minus 3x over x. Okay, and I can either do this as 6 divided by 1 minus 3x over x, or I can say, well, I know how to, if I just multiply the numerator and the denominator of a fraction by the exact same thing, you know, it's still the same fraction because I could just cancel that out. But this allows me to cancel down here. And then I wind up with 6x over 1 minus 3x. Okay, so there's my function. Now I need my domain. So I need to go back and find the domain of g. And the domain of g is, oh, x cannot be 0. X cannot be 0. My domain here is that 1 minus 3x cannot be 0. 1 minus 3x cannot be 0. So that means x cannot be, what would that give me, 1/3? All right, so it's this one and this one. So my domain would be negative infinity, not -8, negative infinity to 0, or 0 to 1/3, or 1/3 to infinity. Right? So I'm going negative infinity to infinity, but I've got to take out 0, take out 0, take out 1/3, right? And that's my domain. Okay, let's try it again, except different. Let's do g of f. So g of f means I'm going to start with the function g, and everywhere there's an x, like right here, I'm going to put the function f, which is 6 over x minus 3. Once again, I get a complex fraction. Can't have that. So it's just like right here, right? I can multiply by whatever this denominator is, as long as I do the same thing to the top and the bottom, so that this can be eliminated, and I'm only left with x minus 3 over 6. Okay, now I need my domain. So my domain, this one, I don't have any problems. This domain, I do have a fraction, but not a fraction with a variable in the denominator, right? There's no way this denominator can be 0. It's 6. It'll never be 0. So this is all real numbers. But I need to go up and look at f. Oh, I've got a problem here. My domain in f cannot be 3, right? X cannot be 3. So my final domain down here is x cannot be 3. So negative infinity to 3 or 3 to infinity. Okay. All right. Let me know if you have any trouble with these compositions, combinations, domains, or difference quotient. And I'll see you next time. Bye.